not surprisingly, having the right amount of hormone, not too much, not too little, is quite important. If anything is going wrong with a particular gland, then you can have problems, whether it's hyposecretion, hypo less, so it's not putting out as much as it should, or hypersecretion, too much of it. Either one of these can be a problem. Another potential problem is if the gland's doing its job just fine, but the receptors are not doing their part. And so, like type 2 diabetes, good example of this, where you're putting out some insulin and the cells aren't responding to insulin the way they should. And so you get problems there. Again, brain. The hypothalamus is a region kind of in the middle of your brain, and it plays a major role in overall coordination of the endocrine system, including signals from the rest of the brain, telling what's going on that may need a hormone response. And it also is involved in regulating what the different endocrine glands do, things like that. A small gland in your brain, the pituitary gland, closely associated with the hypothalamus, and it secretes a number of hormones that in turn are key in telling other endocrine glands that they need to, say, increase or decrease their activity, things of that sort. So it's sort of a master gland regulating other glands. An example of an organ that we've mentioned before that also has an endocrine role, the pancreas. Digestive, secretes various enzymes, for example, some of the ones helping digest stuff in the small intestine, and also chemicals helping neutralize that stomach acid so that the intestine things there aren't all acidic. But besides that, it also secretes hormones, including key ones involved in the regulation of the balance of glucose in the blood. Glucose, again, that's your standard go-to for breaking down with glycolysis and into the mitochondria to make ATP. So you're using plenty of glucose, you want an adequate supply in the blood, but you don't need huge amounts of it floating around. That's going to mess up your chemical balance as well. So having the right amount, not too much, not too little, as is typical of homeostasis, is a very important function in the body. And so we have the insulin and the glucagon, the two key hormones maintaining the balance. Insulin tells cells to take up the glucose. We've got lots of glucose here, use this. And it also says we've got plenty of glucose, so don't release more. The liver is the main organ that is actively releasing glucose. If, however, your glucose is gone, then glucagon is the enzyme that says we need more glucose in the blood, and so it triggers the liver cells to break down glycogen, which is a polysaccharide, lots of glucose molecules stuck together, kind of like starch, which is what plants use in the same sort of way. And so that will release more glucose. If we have more of the glucagon, insulin says use up this glucose, store it away, don't release more. And of course, if things are not in balance, then you can have various diseases such as diabetes. If the insulin isn't being effective, hypoglycemia, if you tend to have too low glucose, variety of issues there. One very important situation that triggers all sorts of endocrine response is stress. And something that no doubt you've encountered in your career as a student. Stress, of course, the brain detects things aren't good, I'm worried here, and so hypothalamus responds to that, sends out signals both by nerves to the adrenal medulla, that's a gland on the kidney, well, two of them, one on each kidney, and in turn that secretes key hormones that trigger stress responses. And also the hypothalamus secretes chemicals that trigger the pituitary. And that sends additional hormones, also tending to act on a different part of that same adrenal gland on each of your kidneys. And then these hormones trigger further responses in the body. Now, of course, doing something about stress is a good idea. So, for example, imagine prehistoric setting. You see some big, hungry-looking animal coming towards you. Getting response going. Get the heart beating faster. Convert more of our stored glycogen to glucose. Dilute the blood vessels going to the brain and muscles. Constrict the ones to the places that aren't needed so well. All these will tend to help you to run more, fight more, whatever you have to do there to deal with the stress. Likewise, our cortisol, this stimulates processing of nutrients in ways to help to promote more energy, ready to use, more sugar in the blood, again, getting you ready to do more running or fighting. But you've probably noticed by now that when a big test comes around, running and fighting are not very useful responses. So you're feeling stress, and your body goes through these responses that aren't exactly what you need for the stress you're facing. Well, okay, things settled down, the test wasn't so bad, you calm down, can deal with that. But if you've got relatively long-term stress, and so your body keeps on experiencing these types of things, this does produce a strain on your body in a number of ways. So long-term continuous stress is not good for you because you're continually stimulating these things to prepare you to do lots of running and fighting and things like that, which the general types of stress we tend to face in our culture, those aren't really the types of response that are needed. Here are a number of the major endocrine glands. Again, our hypothalamus, pituitary are kind of buried in the middle of the brain. Pineal gland is also associated with the brain. It plays an important role in helping regulate the body internal clock, things like that. Thyroid and parathyroid, again, in your throat region. These help regulate a number of body chemicals. Adrenal glands, we're just talking about their role in stress. Those are on the kidneys, pancreas, and of course, reproductive organs have important endocrine signaling as well, directing the body for developing reproductive features, things of that sort. Again, wrong amounts of hormones cause problems. Some widely misused drugs include certain hormones, particularly anabolic steroids. These are hormones that, among other things, tend to tell the body to build up muscle. And of course, some people want to build muscle, and well, there are perfectly good ways of doing that, like exercising. But taking hormones to try to do this, and that tends to cause other problems because hormones have other jobs. Negative side effects. Taking in all this extra hormone tends to throw off the natural balance and regulation of the hormones. So you tend to see impacts on mood, paying attention, mental abilities, like we saw for the stress hormones. This can tend to trigger disease problems. Another thing, these muscle building hormones, they tend to be either actual extra amounts of, or similar to some of the key male reproductive hormones. After all, your average male human does have somewhat more muscle than average female. One of the things that male hormones do is say build muscles in the appropriate place that guys tend to. If you're sticking a bunch of this hormone in you, well, obviously for female, and you're sticking all these male or male-like chemicals in you, this is going to confuse your body, making you think that maybe I'm supposed to be building male stuff instead of female stuff. Not just muscles, but other things too. On the other hand, if you are male, well, your body's getting all this hormone. There's an awful lot of this stuff. This must mean I don't really need to produce more here. So you're not producing the hormone in the way that you normally would. It's not providing the normal regulation of male development the way it should, and so tends to actually make males not develop the male features as strongly as they normally should. Of course, this also very strongly reflects when these are being taken. Normally, the reproductive structures in humans are developing very much in early teen years, puberty time range. If someone is taking these steroids at that time, that's really going to be a problem. Also, of course, there's important development as infant. Your average infant, however, is not interested in trying to become a bodybuilder, so the infant is not likely to be taking these in. Now, of course, if the mother's taking these in while pregnant or nursing, well, some of those might be affecting the infant. Someone who's already gone through puberty taking these, well, they're not going to be great for them, but they don't have quite the same vulnerability because they've already developed. Affecting growth. So you certainly have puberty, not just involves the reproductive features, but growing to adult height around that time as well. So you have impacts there. Of course, also you've got the general problem of a lot of these things are illegal, and who knows whether you're actually getting the hormone or some dirt from the guy's backyard, or who knows what. So you've got problems there as well. Besides the anabolic steroids, there are certain other types of hormones with similar problems if they are misused.